Sopa. Well, that's the way we say hello in Panama. Hello, children. How are you people doing? I'm Saurabh Kumar Dutt, and I'm here to teach you people a little bit of physics. Now, children, this awesome scenery that you get to see is that of one of the islands of Bocas del Toro, Caribbean Ocean, Panama. It is here that you will get to see crystal clear waters where you can see coral reefs, colorful tropical fish, and do scuba diving as they are really shallow. Make sure to have the favorite desert of Panama, Mama Lena, and also to tell all the people of Panama that you get to meet Sopa. In this note, children, I'm going to start off this lecture where today we'll be discussing in physics electric current, where today primarily we'll be talking about three terms: electromotive force, EMF, terminal voltage, and voltage drop. So let's get started, children, and here we will start off again with a simple cell. If you remember, we have had an earlier lecture where we've discussed the electric cell in detail. I'm sure you would want to have good knowledge about it, so make sure you do a revision from that lecture and then come to this lecture to understand EMF, terminal voltage, and voltage drop. So quickly revising a little, let's say we talk about a simple cell here. So it contains a glass container where there is some electrolyte, right? And then there are two electrodes, and connected with these electrodes are copper wires which bring the cathode and the anode in connection. The cathode is the negative electrode, that is, which has excess of electrons, and anode is the positive electrode which has deficiency of electrons. Now remember, children, there is one term which is known as the open circuit. So here in this part of the discussion we will be talking about some important terms, and their definitions are also very important, so I will give it to you people. So when we talk about an open circuit, children, remember that the cell is in working condition. That means here the anode and the cathode, they are attached, right? But in the external circuit, that means where there is a wire attached from the anode to the cathode, there are no electrical devices attached. That means no electrical devices are consuming some electrical energy which has been produced from the chemical energy by the electrolyte, right? So what did I say? An open circuit is such a circuit where the electrolyte produces the electrons, the cathode are getting the excess of electrons, the electrons are flowing from the cathode to the anode by means of a closed copper wire. But in the closed copper wire, which is known as the external circuit, there are no devices which are attached. Okay, so this is an open circuit. So next, children, after this we'll be talking about a closed circuit. So what is a closed circuit? A closed circuit is when in the external circuit we have some devices which are attached, like here. So if suppose we have a properly working cell such that the cathode and the anode, they've been attached by a copper wire, and in this portion where the wire has been attached between the cathode and the anode, there are other electrical devices, like here we have an ammeter, a resistance box, there can be a bulb, there can be other electrical devices which can be attached in the external circuit. Then the circuit will no more be known as an open circuit, it will be known as a closed circuit, as all of these electrical devices, they will be using up some electrical energy given from the cathode moving over to the anode, right? So I'll just quickly discuss what is a closed circuit. A closed circuit is such a circuit in which there are electrical devices which are attached in the external circuit. That means in the join of the wires between the anode and the cathode, and these electrical devices, they use up some of the chemical energy which has been converted to electrical energy, right? And as such, then this circuit is no more known as an open circuit, it will now be known as a closed circuit, right? Now children, I will quickly discuss EMF by means of both of these terms that we had just now, that is an open circuit and a closed circuit. Now, whenever we talk about the potential difference between the anode and the cathode, right, when the cell is in open circuit, then this potential difference will be known as the EMF, right? So children, now I will write this definition. So now we are talking about another important term, that is EMF, right? And I like you people to write along with me so that you are able to learn it very well. So what is EMF? The potential difference between the terminals of a cell when the cell is in open circuit is known as electromotive force, or in short form we can call this to be EMF, right? So this is what I told you people just now, that if the cell is in open circuit, that means in the external circuit there are no devices attached, then the electrical energy is not going to be consumed, the circuit will be known as an open circuit, and then the potential difference between the terminals of the cell will be maximum, and that maximum potential difference is known as the EMF, or the electromotive force. Is this clear with everybody? Aryan? Sure? Very good. Now children, after this we will now be next talking about what is the potential difference between the terminals of the cell, or between the anode and the cathode, known as when the cell is in closed circuit. That children is terminal voltage, right? I'll leave a little space between EMF and terminal voltage. Why? I will tell you a little later. If you can think of, then that will be very good. So now children, we are trying to define terminal voltage. So what is terminal voltage? When we talk about the potential difference between the terminals of the cell, that is between the anode and the cathode, when the cell is in closed circuit, then this is known as the terminal voltage, right? Obviously, as the different electrical devices, they will consume some of the electrical energy, so the potential difference between the terminals of the cell will decrease, right? And thus EMF is always more than the terminal voltage, right? We will discuss this more in detail just now, but first I will make you people write this definition. That is, what is terminal voltage? The potential difference, please write along with me so that you can also understand what you have just learnt, between the terminals of a cell when it is in closed circuit is known as terminal voltage. Right children? So these, that is the definition of EMF and terminal voltage, are just one definitions. Now after this we'll be discussing with another definition of EMF and terminal voltage that is possible, and that will give you more understanding about both of these concepts. Now children, we will be talking about another third concept, Now as you see that here there are two portions. One portion is the external circuit, where there is copper wire and the electrons are traveling within the copper wire, either from the cathode to the anode, or they are moving from the cathode to the anode, and in between they are also passing through these different electrical devices which are attached. They will not be passing through any electrical devices if the circuit is an open circuit. However, if the circuit is a closed circuit, they will also be passing through these different electrical devices. And now you people know that then the potential difference between the terminals of the cell will be no more known as EMF, it will then be known as terminal voltage. Now, except the electrons traveling in the external circuit, there is also some internal circuit, that is the electrolyte of the cell. So when the electrons are moving in the electrolyte of the cell, right, that means when the electrons are being gathered from the electrolyte of the cell, from the chemicals which are there, then what happens is the anions and the cations. Anions are the negatively charged ions and the cations are the positively charged ions. They move in opposite directions and they discharge themselves. And in doing so, what happens is there is obstruction offered, there is collision which happens between the different type of ions. As such, there is resistance which is created, which is known as internal resistance. A little of the energy is consumed by the internal resistance, which is known as voltage drop, right? So what is voltage drop? Voltage drop is the drop in potential due to the obstruction offered by the internal resistance of the cell, and that is the next definition which is there for you people. So now we'll be talking about voltage drop. Please write along with me so that you can learn in a very efficient way. The drop in potential between the terminals of a cell when the cell is in closed circuit then the drop in potential between the terminals of the cell when the cell is in closed circuit is known as voltage drop. Now children, remember one more thing. After we talked about the voltage drop, how do we represent the EMF? The EMF, children, is represented by epsilon. What is this? This is a Greek alphabet which is known as epsilon, right? So this is how we represent EMF. Then the terminal voltage can be said to be, say, some V, right? And or you can write it to be, say, some V1. This is no proper abbreviation. This is just an abbreviation which I'm giving because in times to come then I'll be discussing a derivation which will relate all of these three. So let us say we talk about the terminal voltage to be V1 and the voltage drop to be V2, right? So here children, you understood this, that if we talk about the EMF, then the EMF is the largest potential difference between the terminals of the cell, that is when the cell was in open circuit. The terminal voltage became a little less, right? Because the different electrical devices, they were consuming electricity, right? And because there was some obstruction which was offered in the electrolyte of the cell. So as such, the terminal voltage is lesser than the EMF or the electromotive force, right? And if you talk about their difference is actually equal to the voltage drop. That means the voltage drop if added to the terminal voltage, gives you the EMF, right? So this is the relation that we have between the EMF, the terminal voltage, and the voltage drop, which in times to come we will be generating, right? So meanwhile, we will just write this relation, that is, if you talk about the EMF or the electromotive force, then that's equal to the terminal voltage plus the voltage drop, right? So at the moment we have this relation. In times to come we are going to derive this relation, but before that we will be discussing about the alternative definitions that we can have of all of these three different terms. Now first comes the EMF. So what is the EMF? I'm sure you people remember this, that when we talk about the potential difference, we talk about the ratio of the work done in moving a unit positive charge to the magnitude of the charge in between 2 points in an electric circuit. I'm sure you must have looked up the earlier lecture where I have discussed what potential difference is. If you haven't, please look it up properly, right? And then you'll be able to understand what is electric potential, what is potential difference between 2 points. For that matter, I'm sure you people are liking this lecture. If you are liking this lecture, make sure to subscribe to the channel if you are new to the channel, and press the bell icon so that whenever there is some such informative lecture which I have for you people, you don't miss it out, right? And if you're liking it, obviously you should be pressing the like button. That really gives me quite a lot of confidence, right? And if there are some friends of yours who should have an access to such sort of lectures, some cousins, some acquaintances, do share it with those people also, so that they also understand this part of the physics really well, right? So let's now move on to talking about the potential difference. So this is a definition of potential difference that we've already discussed. That is, it is the ratio of the work done, right, to the magnitude of the charge in moving it from one point to another point in the electric field of a group of charges. Now children, I'm sure you people are able to see that here also we are talking about the EMF to be some potential difference, the terminal voltage also to be some potential difference, and the voltage drop also to be some potential difference. So again we will be talking about them to be the ratio of some work done to the magnitude of the charge. So how can we define these three terms with regards to this definition? That is now what we are going to discuss, and that is why I have left spaces here where we'll be filling in the definitions of this type of explanation. So when we talk about the EMF, children, the EMF is the ratio of the work done by a unit positive charge with the magnitude of the charge. We are going to divide, right, like this, in moving the charge through the whole circuit. Now remember children, in the whole circuit there are two parts. One part is the external circuit where there is just copper wire, right, in between the anode and the cathode. If it's just wire, then just the wire. If there are other devices which are attached, then through those devices also, right? So this is the external circuit, and the internal circuit is through the electrolyte of the cell. So when we talk about an open circuit, then the ratio of the work done to the magnitude of the charge in moving a unit positive charge in the external circuit and in the internal circuit, right, is known as the EMF between the anode and the cathode. So this children is the alternative definition, which gives you an idea in accordance with the earlier discussed definition of electric potential. So next now we'll be talking about writing this definition. So along with me, please write this definition so that you can very well understand what exactly this is. So alternatively, we will talk about the definition of EMF, the ratio of the work done. Please write along with me for better understanding. To the magnitude. The magnitude means the numerical value of a charge in moving the unit positive charge through the whole circuit. Now, whole circuit means external and internal. Internal is the electrolyte, right? When the cell is in open circuit, is known as EMF, right? So again, I'll read it out to you people. The ratio of the work done to the magnitude of a charge in moving the unit positive charge through the whole circuit, external and internal, when the cell is in open circuit, is known as EMF. Now remember children, open circuit is when there are no electrical devices which are attached in the external circuit. Now next, in a similar way, we will define terminal voltage. What can we say? The ratio of the work done to the magnitude of a charge in moving an unit positive charge in the external circuit, that means between the anode and the cathode, only, is known as terminal voltage, right? So if suppose we talk about moving this unit positive charge only in the external circuit, then the ratio of the work done to the magnitude of the charge gives us the potential difference between the anode and the cathode, which is known as the terminal voltage, right? So reading it out, the ratio of the work done to the magnitude of a charge in moving an unit positive charge in the external circuit only is known as terminal voltage, right? After this, similarly, we'll be talking about defining the voltage drop. So similarly children, it can be defined as the ratio of the work done. Please write along with me and put your mind fully to it so that you can understand this also, and so that memorization can also happen simultaneously. To the magnitude or the numerical value of a charge in moving an unit positive charge in the very important thing, internal circuit, that means the electrolyte, only is known as voltage drop, right children? So this is the voltage drop. So when we talk about the ratio of the work done to the magnitude of a unit positive charge in moving it only in the electrolyte of the cell or only in the internal circuit, then it is known as voltage drop. Now, like we've discussed here, that when we talk about the relation between the EMF, the terminal voltage, and the voltage drop, we can say that the electromotive force is actually the sum of the terminal voltage and the voltage drop. Now, let us look it up numerically by derivation how this is possible. So, I'm sure you know this, that if we talk about the law of conservation of energy, we have this, that energy can neither be destroyed nor it can be created. It can just be transferred from one form to another. So if we talk about the amount of work done or the amount of energy consumed, right, in moving the unit positive charge around the whole circuit, that is, if we talk about the work done which is in moving it about the external circuit and the internal circuit, if added, should give us the total amount of work. So if we consider the total amount of work to be, say, W, and if we consider the work which has been done in moving the unit positive charge in the external circuit to be, say, WE, we require to add to it the amount of work done in moving the unit positive charge in the internal circuit. And if we add both of these, obviously it will be the complete circuit and it will be the total work done or the total energy consumed in doing this amount of work, right? Now, children, we can divide both of the sides of this equation by the magnitude of the charge Q, say. So if we do so, children, next now what we have is we will now be having this W, which is going to be divided by Q on the left hand side, and on the right hand side we will have WE divided by Q and WI also divided by Q. Now next, children, if we talk about W upon Q, we know that this is a expression for potential difference, and this is an expression for potential difference when we are talking about the whole circuit, or in other words, we are talking about this to be the electromotive force or EMF. And when we talk about the external circuit only, we've already defined that this means that we are talking about the terminal voltage. And when we talk about the work done in moving the unit positive charge in the internal circuit, we know that that is the potential difference, and thus this gives us an expression that when we talk about the EMF, it is actually what? It is the sum of the terminal voltage and the voltage drop, and thus this is a very important relation which in times to come you will also be using in numericals, which has now been derived. So I'll just quickly discuss this once more. What did I say? That when we talk about an EMF is equal to terminal voltage plus voltage drop, right? Earlier ahead here we have written all of this, right? If we talk about this VD, it is actually the voltage drop. If we talk about TV, that is the terminal voltage, although these are not proper abbreviations, these are just abbreviations for our ease only, right? They are not accepted abbreviations. Don't use them in your answers. Okay, now here we've talked about, by the law of conservation of energy, we know that if we talk about some work, then that will be equal to some work done for some purpose and the other work done for some other purpose. So here we have the total work in moving a unit positive charge about the whole circuit. So obviously it will be equal to the amount of work done in moving it in the external circuit plus the amount of work done in moving it in the internal circuit. For that matter, the amount of energy used in doing the complete work will be equal to the energy used in the external circuit and the energy used in the internal circuit. Now, by the law of conservation, we have this. Now, if we divide both the sides by the charge Q, then we'll have W upon Q to be equal to WE, that is the external circuit, divided by Q, plus WI, that is the internal circuit, divided by Q. And since earlier, if you remember, we've already discussed this, that if we talk about V, then that's equal to W upon Q. That is, the potential difference is equal to the ratio of the work done to the magnitude of the charge. So this thus gives us the potential difference. Now, for the whole circuit, the potential difference between the terminals of the cell will be known as EMF, and when it is just the external circuit we've just discussed, that is the terminal voltage, and if it's just the internal circuit, then it's the voltage drop. Thus we get a relation that EMF is equal to terminal voltage plus voltage drop. So this is a very important relation. Do learn it up, because in times to come, next now when we're going to do numericals, we'll be using this expression. So how did you like this lecture? Do write to me, and what else you want to study, write to me in messages. Make sure that you study all of this and make this really perfect with yourselves. Bye for now. Have a nice time.